Okay, doesn't look like Newton eases us into these problems. But the big idea here is that if you have f of x equals e to the x, the derivative of f of x is e to the x. The derivative is itself. It describes its own rate of change. Okay, but the chain rule has to apply with these exponential functions base e. Okay, this is e. It's an exponential function because there's a variable in the exponent, but the base of the exponent is e. So if you have something like this, oops. Then the derivative is itself, the derivative of the outermost function of the exponent is itself, but then it's times the derivative of the innermost function. Remember, with the chain rule, you're looking for potential composite functions. This could be a composite of the base e exponent function. So we have to multiply by the derivative of the next innermost function. And using the power rule, the 2 comes down and multiplies. That's 8x to the first. So we got to remember to use the chain rule with this problem. When we try to find k prime, the derivative, it's itself. That's the crazy thing about an exponential function of base e. So the derivative is itself, but then we need to chain on the derivative of the innermost function, this up here. So the power rule applies, the negative 5/3 x to the 2/3, because the power gets reduced by 1. The 3/2 comes down, and the power gets reduced by 1. So there is our derivative. So this one's a little bit different though. This one we're going to need to use the, let's see, this one we're going to need to use the product rule because this is a function of x and this is a different function of x. So the product rule for differentiation says the derivative of the first function, which is itself, so that's nothing too complicated, times the second function kept the same, plus the original first function times the derivative of the second function. So the second function, the negative 2/3, comes down, multiplies to that negative 1, so that makes positive 2/3 x to the negative 5/3. Because we get reduced by 1, so we subtract negative 2/3 by 1. And then here the negative 5/4 comes down and multiplies, so a negative times a negative is going to make a positive. And the 5's cross cancel, so we got the 2/4, which makes 1/2 for a coefficient. Then it gets reduced by 1, so that's negative 9/4 here. And then to make Newton happy, let's factor out the e to the x. And what we're left with in descending powers, look, if you factor out an e to the x to both of these, then it's just these terms added to these terms. So let's see, the largest power is negative x to the negative 2/3. That's the thing closest to 0. And then we got 2/5 x to the negative 5/4. And then plus that 2/3 x to the negative 5/3 plus 1/2 x to the negative 9/4. Okay, I think we're done now. So to find the derivative here, 2 different functions of x multiplying, so it's the product rule again. So remember, 2 over x to the 5th, that's 2x to the negative 5th, so you can use the power rule in that one. It's going to be negative 10 over x to the 6. Okay, because if you evaluate this derivative, the derivative with respect to x of this, the negative 5 comes down, it gets reduced by 1, so instead of saying x to the negative 6, you could say something over x to the 6. Kick it downstairs in the denominator. That's the derivative of the first function times the second function kept the same. And then the product rule says you add the original first function, the 2 over x to the 5th, times the second function, the derivative of the second function. Now the derivative of the second function is itself, because there's that exponent base e function that we talked about. The derivative of base e exponents is itself, but then the chain rule has to apply. So I'm going to multiply this by the derivative of the innermost function is 16x to the third plus 12x squared. Okay, so just like in the last problem, we can factor out an e to the 4x to the fourth plus 4x to the third. We can factor that out of both of those terms, and we're left with negative 10 over x to the 6 plus, this is left over when we factor that out, so 2 over x to the 5th times this 16x to the third plus 12x squared. So there's a little more algebraic simplification we can do. I don't want to write that out again, so let me copy and paste that. Okay, this is negative 10 over x to the 6. And then if you distribute that x to the 5th to everything in here, that's going to be 32 over x to the 2nd. And then distribute that over here. The 2 times 12 gives us 24 over x to the 3rd.